An account is an account, bank is an account for investors. The interest is added to the account at the end of each year at a fixed rate of 3% of the amount in the account at the beginning of the year. Okay, Mary and Ben both invest money. Mary decides to invest X dollars at the beginning of each year and then a further X dollars at the beginning of the second and each subsequent year. That means at the start of every year, I invest X dollars. I also decided I'm not going to draw any money. I'm just going to leave it to build up. Alright? And remember, starting of the year, there's something going on. Right? And at the end of the year, there's something going on. So, starting of the year, I'm doing the investment. End of the year, I'm doing the adding of interest. So what we can do is, based on what we've done in the past, you can remember, we can actually do and draw out a table. Right? So maybe this is the so-called the first year. Right? And at the start of the year or the beginning of each year and at the end of the year, something happens, right? So for example, if this is my first year, okay, then I put in maybe X amount of dollars, right? Okay, I put in X amount of dollars. Okay, I put in X amount of dollars. Okay, and at the end of each year, right, what happens is that there's interest going on. So 3% will be added and we actually get 1.03x. And you look at the second year. For the second year, right, again we have 1.03x from the previous year and I add another X dollars. End of the second year, we take another 3%, so it's actually 1.03 because we are taking 3% more. So 100% plus 3% is I'm taking the value times 1.03 of the amount that was inside. So this was the amount that was inside, right? So with that, this is actually my 1.03x plus x. And you can see that actually what's happening is that if I factorize on my x, right, I get x 1.03 square plus 1.03. And then you see something, it seems like looks like there's some sort of a GP going on. Okay, and soon enough, if we keep going down, you can actually try this for a third year, and you can see that actually, right, the amount of money inside the account follows a GP, right, because this amount at the end of each year, the end year, right, it's going to look something like this. It's going to be like x. So second year, you can see power 2, right? So n year, you'll be actually power n plus 1.03 n minus 1 plus plus 1.03 to the power of 2 plus 1.03 to the power of 1 and so on. Right, so that is the idea that we have. Okay, so what's the amount? How do we find the amount at the end of the end year? You can see this actually is the GP. Right, so what we can do, we can just quickly sum it up, and this GP is the first term, right? So it's just x multiplied by a bracket r minus, because r is greater than 1, so it's r to the power n minus 1 over r minus 1. This is the sum of the GP that we're looking at. So I just want to recall sum of GP is just equals to a r to the power n minus 1, r minus 1. This is for mod r greater than 1, and a 1 minus r to the power of n over 1 minus r for mod r lesser than 1. Okay, so that's how I got this formula. Okay, so very quickly I'm going to erase. Okay, and I want you to see that, here, right, this is the amount that I left, and if I were to simplify things further, this will just give me 1.03x divided by 0.03, 1.03 n to the power minus 1, which is the same as 103x over 3 multiplied by 1.03 n to the power minus 1. Okay, so that's for part 1. Part 2, right, show that at the end of the n years, right, when the interest for the last year has been added, okay, I will have this amount. Okay, so we bear into account. Okay, so this is for part 2. Okay, so for part 3, $10,000. I start investing at the beginning of 2016 with $10,000. This means what? In the original question, right, our X now becomes 10,000. Okay, our X now becomes 10,000. Instead of X dollars, I invest 10,000. Okay. What at the end of which year will I have for the first time at least 190,000 in my account? That means I'm trying to find a particular year where my sum of my value in the account, my sum of the money in the account becomes 190,000. It means that actually I want this to be 190,000. Given that my X is 10,000, means I want this to give me 190,000. Okay, so given X is equals to 10,000, given that X is equals to 10,000, the sum of money or the money in the account at the end of n months looks like that, right? It's 103 over 3, right? X. Remember, this was what we had just now. This was the money in the account at the end of n months. But now, right, we want to replace the X with 10,000. So it's 103 over 3, right? Times, times 10,000, which is the original X. Okay? And we want this to be more than 190,000. At least 190,000 must more than equal. Right? So you just bring this number across. You bring this number across. Okay, you're just going to get a quick, nice, beautiful equation. Inequality, sorry. That 1.03 to the power of n minus 1 is just 57 over 103. To find this n, what I can do, okay, so you can see a 1.03, right, will be just 57 over 103 plus 1, and okay, after I log both sides, so n ln 1.03 greater than or equals to ln maybe 103 plus 57, so it's 160 over 103. And quickly you can see that my n at least will be 14.9006, and my answer is that I will have at least so you can see that n is 14, greater than or equals to 14. Right, so what do you mean by 14? Given that I start in 2016, I start at the beginning of 2016. Alright, how many years will I need? So I need at least 14 years. So that means what? I need at least 14 years, right? Because n is the number of years compounding. So what does it mean? It means that I will have, Miss Lee will have at least 190,000 in her account at the end of 2030. Alright, so this is for part 3. How about part 4? How about the part 4? So Ben decided that, okay, to assist him in his everyday expenses, he will withdraw the interest as soon as it's been added. Okay, so every year I invest Y dollars at the beginning of each year and find the total amount of interest he will receive at the end of n years. Okay, so similarly for Ben's case, what we do is to see or to understand such a question fully, it's best for us to draw a table. Okay, so we can actually draw a table, and suppose we have, maybe let's look at Ben's account. Ben's account, right? Okay, I invest, maybe this is year 1. Okay, and at the start of this year, I invest probably Y dollars. Alright, because you say that I invest Y dollars at the beginning of each year. And end of each year, remember, there is what's the interest received? The interest received is 0.03, right? So let's not talk about the value in the account. Let's look at the interest received. Okay, so n of the interest received, maybe n. Let me talk about interest received. Interest, right? Is actually 0.03 y, right? 0.03 y, right? So Y dollars, let me just talk about 0.3. Okay, so I pull out this amount. I left with Y. Year 2, right? Remember, I take out the interest. I'm left with Y dollars. I put in another Y, so I have 2Y. Because every year I put in Y, every year I put in Y. I take out interest. Okay, so you think about it. End of this year, I will have 0.03 of 2Y. Starting of third year, I put in another Y. I got 3Y. And then end of the year, I take again 3% of whatever is in the account is 0.03 of 3Y. You can see it goes on, so I have 0.03 of ny. After n years, right, maybe this is ny, right? Not NYJC but ny, okay? Then you can see at the end year end, this is the amount of interest that I have received. So my question is, how much total interest I received? You observe, right? You can see that I have 0.03 of y plus 0.03 of 2y plus 0.003 of 3y plus 0.03 of ny, so on and so forth, right? This is the same. And if I will take out 0.03y on purpose, right, you can see what do I have. It's a very nice number. It's a very beautiful number. This is nothing but an AP, right? Number of terms is n. First term is 1, common difference 1, right? First term is 1, common difference 1. Number of terms is n. Beautiful, right? So from here, 0.03y multiplied by, this is actually a summation, n over 2 bracket first term plus last term, and our answer is just equals to 0.015y n bracket 1 plus n, and that's our answer for part B.